Section 2.2, problem number 23. First thing I got to stress to you guys, you need to make sure you're reading your directions here carefully. So I'm reading it right out of the book right now in exercises 17 through 38. Estimate. We're not actually finding, we are estimating a limit, and we are doing so numerically. So in these couple sections right here, we were trying to come up here with numerical or graphical estimates for limits here. And this one here, guys, we're just trying to do this numerically, and that means we're going to be making a table. So the first thing I did right here, guys, and I wish I could show you this on my calculator, but unfortunately the iPad I'm using right now doesn't have the Inspire app on it yet. The first thing I did is I typed this into a calculator page. Define f of, and I went ahead and used the variable theta just because that's the way this function is written, but if you guys wanted, you could just put an x there as well. The theta on your calculator is found, everybody, if you look at the little pi button that is located just to the left of the h, towards the bottom left-hand corner. It's pi, but with a little arrow there. If you click that button, it'll open up a little sub-menu and you can get to theta that way. So I went ahead and did equals, and then control divide to get a stacked fraction, and then I typed in the function just the way it looked above. Cosine of theta, close the parenthesis that popped up, minus 1 all over theta. And then what I went to do is I added a page, guys. So I hit control and then the document button. And then from there, I hit number 4 to add a list and a spreadsheet. And that's how I'm coming up with the values I'm about to put in this table. I'll show you guys this in class because it's a little difficult to describe. But here's what's going on. In my first column here, my theta values, I started putting in negative 0.003. Now, where that number came from is the fact that we're trying to do a limit as theta is approaching this value of 0. So I wanted to start with something ever so slightly less than 0. So I went 3 1/1000ths to the left of 0. And now I'm just going to increase this by 1 1,000th each step. This is certainly not the only way to do it, guys. This is just the way I like to do it. Now, normally what would come next in this table, you'd be so inclined, would be to go ahead and continue the pattern and put a 0 right here. But I've warned you guys not to do that because, and I know we've said this a million times, let's keep saying it, a limit is the y value that your function approaches but never actually hits. So I tell you what, I would tell you not normally to put that there, but I'm going to leave it there for now and then continue my pattern after that. Now we move into positive land, 0.001, 0.002, and 0.003. So typing those values into my table, now I'm going to put each one of them into this f of theta function here that we just came up with. Now, I have to warn you guys, in the upper right-hand corner of my calculator screen, I see a big fat RAD written out, meaning that my calculator is in radian mode right now. That's where you want to be, really, for the rest of the year, guys, anytime we're doing anything that involves trig. If your calculator is still in degree mode, which it might have been if this is the first trig you've done since law of sines and cosines back in chapter 1, you're going to want to change that by hitting your home button, going to your settings, changing your document settings, and then changing degrees into radians. And as I said, we can pretty much leave it there the rest of the year. Now, this got a little bit messy, but I'm going to write out what I can. For my first value here, I got 0 point, and I'm not going to be here all day, but I got 0.014, and then a whole bunch of 9s after that. Now in the second column, or the second row, it actually looks like the number got bigger. It actually went to 9.99 blah, blah, blah. But if you actually zoom in on that, guys, or actually move your cursor right over that, it'll tell you that that number is actually in scientific notation times 10 to the negative 4th. So this is actually 0.000 and then a couple of 9s after that. So this number actually got smaller. And then right underneath that, almost the same thing, 0.000, but now it looks like a 499, ... So, is this enough to get a sense here? As we read this table, as theta is approaching 0 from the left, our y value here certainly seems to be approaching, I think, 0 as well. Let's do the same thing down on the bottom, and I think you're going to start to see some similarities right here. Yep, sure enough, now I'm at negative 0.000, and then a 499, dot, 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 and then negative 0.000, and then it looks like 999, dot, 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 and then a negative, this one is not in scientific notation, 0.00149. So maybe not surprisingly, all these y values we got on the bottom of this table here are just the opposites of the y values we got up above. So, and I read this one now from bottom up, as theta is approaching 0 from the right, our y values seem to be approaching 0 as well. So since both the left and right side limits seem to give us the same information, we can say now that the limit of this function here is equal to 0.